All right, we got two more little sections here, and then I'm going to go ahead and check what questions have come in, and we will close out. So I'll get you right about 1 o'clock. So for consumer product design, there's some new capabilities that have to do with surfaces, both improvements to sketching splines on those surfaces, as well as something that we have called a flat surface. Now, flat surface I'll describe as I do it, but it has to do a lot with a basic interrogation of what a flat version of this 3D body would be. So let's go ahead and jump into those. I want to bring up my surface model for starters, and this surface model is what we call a shoe last. Anybody that's in the shoe industry recognizes these. They're for every size, and in many cases every half size of a shoe, and they're not symmetrical, as in they're not just a common upscale downscale from size 3 to size 13.5. They're very unique in each of their incremental sizes. Within this part, which is an imported surface, we have a sketch. Now, sidebar here, first thing I want to show you on this sketch is that this has a spline in it. And the spline was generated with the original spline functionality that we've always had. The trouble I have with splines, especially when you have these interim points, is that those points get in the way of it being a smooth spline. They control the weighting, they control the angle of attack, they control a lot of crazy things when it comes to the way this spline geometry is actually generated. And it can make for a spline that isn't necessarily a nice, smooth transition from one end to the other. Well, now what you can do is right-click on any spline and actually convert it over to a style spline, which is now my spline of choice. What that does is it creates a spline based on prismatic inputs and a particular amount of geometry. And as I do this, it now gives you the ability to change the contouring of the spline by simply changing the weighting due to some prismatic construction geometry around it. But in any event, this spline is only 2 points now, so it stays completely smooth and never has those very abrupt transitions from convex to concave as a result of the way we make the input. All right, a little sidebar there. Well, we're going to take this sketch and do something we've never been able to do before, and that is the ability to go to my Surfaces tool and actually do a trim. Or we can always go ahead and go to our Features tool and do something called a split. Now, the split would actually allow me to take this sketch and use it, projecting it onto that surface, to cut this surface into many individual pieces. So now individual bodies within this single part file. We're going to take all those and keep them. Visually, it doesn't look like we changed anything, but what we did do is we made 4 unique bodies. What that gives us the ability to do is select a body and actually isolate it from the rest of this design. Now, this is a surface body, and what I'm going to do is go to my sketch tools, and we're going to sketch a spline on a surface. This feature also has been around for quite some time. So with this tool, we're going to just go ahead and select it and simply draw on this surface. And what's odd about this, and I'm saying odd in a very good way, is that it appears from the user that we're just kind of adding coincident points. So I'm just clicking once, clicking a second time, and then I'm going to infer to this edge back here and just double click to finish it. So what this looks like, again, is just coincident points on a surface. But if I roll this around, the reality is that it's as if I stood above this surface and dropped a piece of spaghetti down on it. You can see that every point along that spline is completely coincident with that 3D surface. It allows us to manipulate this geometry by dragging it around. You can even see a delta change on that point as it wraps around the front of the surface. But it allows us to go ahead and make relationships and have very nice, clean geometry around this. I'm going to use that 3D sketch now, and in this case we are going to do a trim. So on my Surfaces tool, I want to trim, and we can choose the piece that we want to keep, which is just going to be this nose of this boot. And that gives us this very, very organic shape and more of a bow tie type of a look. Well, now we can take this surface and do an operation called Flatten Surface. So with Flatten Surface, I'm going to window select here just to get everything, pick the ones I missed, but then we need a little vertex to determine where we're going to flatten from. And as we do this, we get a preview of it automatically. Now, I need to caution everybody on this. This tool doesn't have a lot of inputs. We have high and low accuracy, and that's about it. There are third-party applications like ExactFlat, which is a product we represent, that will take into account the type of material that we're flattening. Because obviously if I was flattening fabric, which is a weave, weaves map to contours very easily, but leather does not. It's still flexible, but it doesn't like to bunch and stretch and thin and move with the shapes. So the material has a lot to do with it. Metals have stretch and elasticity factors. They're going to thin, they're going to bunch, they're going to oil can, and they're going to tear. And those are the types of things that ExactFlat would actually symbolize. Here we're going to get a nice look at this. We're going to show what is basically a good estimate representation of this. And it does generate a physical surface, so an additional surface to the originals. This surface can be interrogated by right-clicking on it and showing a deformation plot, But again, this deformation plot isn't based on a real sophisticated algorithm taking into account all of the factors. So it looks good. It's a great representation at this point, but it's only going to get better with user input on how we want to make this thing a much more robust type of analysis tool. And I'm not sure it's going to go much further than it is right now because, once again, we have solution partners out there that have great products that already do this. So unless the solution partner is going to embed their product into SOLIDWORKS, which has happened frequently in the past, take this one with a nice representation, but not necessarily as a hardcore analysis type of a feature. Last